Well, the welder just caught on fire. The overheat thing apparently does not work on it. It's nice. Hey guys, so I guess it's time to take this welder apart and see what's going on with it. This is a Chicago Electric flux welder. I think it's 125 amp. It's whatever the cheapest model is that they have. And I converted to DC and apparently used the wrong type of wires. And it melted and caught on fire and everything. So we'll see if it's something we can fix or not. Okay, so if you look here and see what all's burned up, is basically what I added to it, which we kind of looked at it before. And this is that cheap wiring I bought, and I thought would be sufficient, but apparently not. It looks like it may have burned up the control transformer, the control power supply transformer. And I think that's the only thing that's actually wrong, because the coils and everything in the transformer still look good. It's just all the stuff over here, and plus the on-off switch is pretty much toast too. The capacitor should be still good, unless the rectifier did short out and cause something to pop or something. But we'll just have to see and check out that transformer and see if it's something I already have that we can maybe replace and go from there. Wires are junk. Alright, so I got the power bypass straight to the transformer, except for the minimum max switch. And obviously I don't recommend doing this, but it appears to be working. I'm going to get a voltage reading on this and just kind of see what the open circuit voltage is and go from there. So with on the maximum setting we're reading 28 volts, and on the minimum we're reading 22, so I'll have to look up and see if that's about what these are supposed to be putting out. But it appears that the transformer is good, so that's a big plus. So if all else fails, if none of the control stuff will work, we can make a small portable DC rod welder out of it. Alright, so digging a little deeper, chances are this transformer is probably burned up. Yeah, it has to be. You can see everything just melted off of it. Now we can try to hook it up just to make sure. I'm going to assume that the blue wires are the primary. Well, who knows, it could just be exterior. I cannot make out what it says on here. I can make out output, and I can't see nothing where the label's burned up, so I'll have to try to find a schematic or contact Harbor Freight and see if there's a way I can just buy this transformer. I don't want to find out what the voltage was, because I might have something laying around, because I got all kinds of old parts. So let me try and trace this wiring and see if, I'm pretty sure these blue wires would be the primary side, because it was hooked in parallel, what I could tell, to the 120 volt fan over here. Which the fan works too. I just hooked it up. The fan works, the transformer works. I put the two output wires together and it started heating up and kicked the breaker. So other than smoke from my little tie-in wire, I didn't see nothing wrong. Also on the capacitor, it looks like it, I don't know if it's just fire damage or if it was actually arcing right there or not. So I got more of these. We might just put a new capacitor, and obviously we'll put a new rectifier in there too. This is for 150 amps, so it should, I don't think that was the problem. I'm pretty sure it was the wiring that I put in there. Yeah, the transformer ain't no good. Waiting for the smoke to clear out. Alright, so I found a replacement on eBay. It just happened to be one on there at the time I needed one. It's funny how things work out. Looks a lot better than the old one, so that'll take care of that part of it. Still need to get a switch, because this one don't feel right, and pretty much rewire everything. I'm not going to go into an extreme amount of detail on the video, but I will share with you how I convert it to DC though. So we'll look at it after we get everything back together, and hopefully it works. Okay, since this switch is completely toast, I had to pretty much bypass everything. It's going to be all done better when I get a new switch in. Get everything hooked up, plug it in. I cut the wire here. I didn't even think about, doing that at first. So now when I squeeze the trigger, mind you, the transformer's not hooked up. Now I think we're working. That's all that. Then I put the pair of needle nose across this. Let's see if we can. I don't recommend doing this. So it's working. We just gotta get the fan hooked up, which is no problem. It'll just go across 2 of the hot wires, and it works. I already tested it. And get a new switch and wire in the new rectifier and capacitor. Alright, so this is the type of switch I'm putting in it. It's a blue one instead of a green one. I believe it was in it. And it should work just the same. It'll fit right in there. Got an extra one in case we ever need it for this or something else. So I'm going to skip most of the wiring on this. We'll look at it here after everything's hooked up and go from there. Almost done with the wiring. I got it working. One little disappointment. Let me plug it in and show you. This light don't light up blue. It lights up orange. But it'll work. You're going to get a bad review on Amazon. Anyway, it's wired up with slightly different. I got everything to work. I was getting ready to wire up the rectifier. I just assumed that this one's bad because where that got burnt right there. But the only other rectifier I have is actually just a 100 amp one. That's a 3-phase rectifier. This is 150, and so this is obviously not going to hold up, even though it is bigger and it's got a built-in heat sink. So I'm going to have to use this one. I checked it and it's still good, so shouldn't be no problem. I might try to come up with a slightly different way to mount it to the heat sink, so maybe it cools a little bit better. But we'll look at it here in a minute. We'll get everything wired up. Only thing left to wire up is this indicator. I'm not too worried about it because I know if it shuts off, that's what the problem is. But we'll probably hook it up anyway. So I had a thought about relocating the rectifier and extending the wires over here closer to the fan, but that's not the problem. Like, what overheated was that cheap wiring I put in there, this audio type cable, which is actually aluminum. Just cheap stuff. It's good for certain applications, but not for this. And that's what you get for trying to save money. But so obviously, the rectifier didn't overheat. The wiring did, so that shouldn't be a problem. And the transformer don't have no signs of damage either. So it was just that wiring was the problem. So we're just gonna put a lot better quality wire in here and hope for the best. So this is just 6-gauge house wire. It's extremely stiff and hard to work with on something like this. So the wire is pretty much going to hold the rectifier in place. The heat sink's already bolted to it. All the other wiring is clear away from it, so there's no issues with that. And this is just bent up. It's just the way the piece is made. Hopefully it'll be okay, and we're just going to see what happens. Alright, so it's working. And I don't recommend doing this, but I just got this directly shorted. That's the high, and this is you can hear the feed is working. It's all the way up on 10. Put it on minimum. I think we're working, guys. I don't know whether to try this wire or not. I might try to clean up a little bit of it and see if I can just do a little test weld with it just to make sure that it is going to work good. I had the voltmeter hooked up to this and it's putting out 39 volts DC open circuit on maximum, 29 on minimum, and it's got a don't forget about 150 ohm or 100 ohm wire wound resistor on here. That'll bleed the capacitor down, so there's never charge on here except for just a little bit as soon as you first stop. But it takes a few seconds for it to bleed off. Everything's staying nice and cool. The resistor is getting warm when it's on, which is normal because it's a wire wound resistor. So let's get it all back together and hopefully do a test weld with it. I'll put it on 5, got it on max. I'm just going to try to weld a bead here. This is the rusted wire. I don't recommend using that because it can damage the cable inside there. It's more or less just surface rust. So I think it'll be fine. There's probably rust inside the cable too. So if we get a very bad weld, that's the reason. I mean, it's laying a bead, so we should be alright. Let's crank it up, speed up a little bit. I'm gonna shut the welder off, unplug it, and just kind of check anything, see if there's anything hot. Capacitor's cool. The rectifier is just barely warm. Transformer's cool. Fan's cool. Circuit board's cool. I think we're okay, guys. I think we got it. Well, I'm gonna call it fixed, guys. The only thing I just remembered, literally when I started the cameras, I forgot to wire up that, but not that worried about it. If it shuts off, we know it's probably too hot. Disappointed in the color of the switch, but it'll be fine. So, with all this being said, don't buy one of these and convert it to DC. If you already have the components on hand to convert one to DC, then go for it. But if you can afford just a little bit more, get one that's already DC or the inverter type. You'll be better off in the long run. I just did this as kind of like a hobby, you know, and obviously if I didn't do that to it, it probably never would have caught on fire. With that being said, you do get 100 times better weld with DC instead of AC on Fluxcore. So it's recommended to use DC Fluxcore, but I don't really recommend buying one of these and then plan on buying all the parts to convert it to DC. With that being said, I hope it holds up. We got a couple decent welds here. This last one's on high, on 4. That was on 10 all the way up, just kind of testing it, and that was on 5 or 6, I think. So about 4 or 5 is about the sweet spot on one of these. For this is 1/8 inch metal. It's left over from the top of the workbench. It's probably cut out from the engine stand. So, well, guys, I'm gonna try to keep this video from getting too long. Hopefully we can try it out more on the next project, whatever we have to weld. I did get kind of used to using the rod welder for most of the summer, but I do prefer this, especially for thinner metal. And if it's something I want the weld to look good, because I can get a better bead with the MIG than I can with the rod welder. Alright, guys, so we'll catch you on the next video. Questions, comments, suggestions. Also wanted to say, if I have any problems with this at all after this point, I will be buying a new one. I just thought I would try to fix it, make a video on it, so hopefully it holds up. It's not like it's used 8 hours a day every day anyway. So, alright, guys, so we'll catch you on the next video. Thanks for watching.